Hello dear students, in this video I'll continue with Unit 3C Differential Equations. In this video I'll solve the questions from exercise 5. In my previous video I have explained various growth and decay models with the example questions from CBSE Handbook. The knowledge of those models is required to solve the fifth exercise, which we are going to see now. The first question, find an exponential growth model y equal to y naught e raised to kt that satisfies the stated conditions. So we need to find an exponential growth model given by y equal to y naught into e raised to kt for each of these subdivision and which satisfies each of these condition in each subdivision. The first subdivision is y naught equal to 1 and doubling time t equal to 5 years. First let us write the model. We have y equal to y naught into e raised to kt. The first subdivision y naught equal to 1 implies y is equal to e raised to kt. So this is the model and it is given doubling time t equal to 5 years. Given t equal to 5 for y equal to 2 times y naught, 2 into 1, which is 2, implies 2 is equal to e raised to 5k. So from this we can find k. Let us take log on both sides. Log 2 to the base e equal to 5k into log e to the base e. Log e to the base e is 1. Using the laws of logarithm, log a raised to m is m log a. So log of e raised to 5k will be 5k log e to the base e. Log of any number which has base to the same number is 1. So log e to the base e is 1. Log 2 it is given in the question, it is 0.693. This implies 5k equal to 0.693 or k equal to 0.693 divided by 5. So this is 0.1386. Therefore the model is y is equal to, we have y naught as 1 and we got k as 0.1386. E raised to 0.1386 t. This is the model. Moving on to the second subdivision. Y of 0 equal to 5 and growth rate equal to 2%. So in the second subdivision, y of 0 equal to 5 means it is nothing but y naught equal to 5 and growth rate. This growth rate is nothing but it is k. K is the growth rate and k equal to 2%. It is 0.02. Therefore the model is y is equal to 5 into e raised to 0.02 t. So this is the exponential growth model which satisfies these conditions. Y of 0 equal to 5 and growth rate equal to 2%. Now moving on to the third subdivision. Here y of 1 and y of 10 are given. We need to find the model. That is, we need to find y naught and we have to find k. Substitute it here so that we will get the exponential growth model. Third subdivision, y of 1 equal to 1 implies, here we have to substitute t as 1 and y of 1, that is y as 1. Implies y is equal to y naught into e raised to k. Y of 1 equal to 1 means when t equal to 1, y equal to 1. And then y of 10 equal to 100. Y of 10 equal to 100, the meaning is that when t equal to 10, y equal to 100. So 100 equal to y naught into e raised to 10k. Let us take this as 3 and 4. These two are from 1. Now let us divide 4 by 3. Divide 4 by 3. So 100 equal to y naught e raised to 10k upon y naught e raised to k. Here y naught and y naught will cancel. We get 100 equal to e raised to 10k upon e raised to k is e raised to 10k minus k, which is e raised to 9k. Using laws of exponents, a raised to m upon a raised to n equal to a raised to m minus n. So e raised to 10k upon e raised to k will be e raised to 10k minus k, which is e raised to 9k. Now let us take log on both sides. From this we get log 100 to the base e equal to 9k into log e to the base e. This is 1. So from this we get k is equal to log 100 by 9. Log 100, if we consider it as given in the question, log 100 the value is 4.605. So it is 4.605 by 9. Therefore k is equal to 0.51. This is 0.51. Now we got k. Let us substitute k in the third equation and let us find y naught. 3 implies 1 is equal to y naught into e raised to 0.51. Or from this we have y naught as 1 by e raised to 0.51. It is e raised to minus 0.51, which is given here. So y naught is e raised to minus 0.51. It is given as 0.6. Therefore the model is y is equal to y naught. Y naught is 0.6 into e raised to kt. K is 0.51. 0.51 t. So this is how we can get the exponential model for each of these stated conditions. Now moving on to the next question. Gaurav deposited rupees 5,000 in an account which is paying 3% interest compounded continuously for 5 years. Find the total amount at the end of 5 years. How long will it take for the money to double? So here we have the amount that is deposited and the rate of interest given, and here the interest is compounded continuously for a time period of 5 years. We need to find the total amount at the end of 5 years and we need to find the time taken for the money to double. So given initially the amount deposited was 5,000. So A naught is 5,000. And then interest R is 3%. So it is 0.03. If we consider A as the amount deposited for time t, then we know using the compound interest model, A equal to A naught into e raised to RT. Or we have A equal to A naught is 5,000 into e raised to R is 0.03 t. So let us mark this as 1. Now let us do the first subdivision. Find the total amount at the end of 5 years. So for the first subdivision, when t equal to 5, 1 implies A equal to 5,000 into e raised to 0.03 into 5. So it is 5,000 into e raised to 0.03 into 5 is 0.15. E raised to 0.15, the value is 1.1618. So this is 5,000 into 1.1618. This when we multiply we get it as 5,809. So amount at the end of 5 years is rupees 5,809. Now the second subdivision, how long will it take for the money to double? We need to find the time in which money will double. For A equal to 2 times A naught. A naught is 5000. So for A equal to 10,000, from equation 1 we have 10,000 equal to 5000 into e raised to 0.03 t. Or here 10 by 5 is 2. 2 is equal to e raised to 0.03 t. Let us take log on both sides. Log 2 to the base e, it is equal to 0.03 t. Into log e is 1. Now log 2 to the base e, it is 0.693. 0.693 equal to 0.03 t. Or t is equal to 0.693 upon 0.03. This is equal to 23.1. Therefore, t is equal to 23.1 years. The time in which rupees 5000 will double is 23.1 years when the rate of interest is 3%. Next question. In a certain culture of bacteria, the number of bacteria increased 5 times in 10 hours. How long did it take for the number of bacteria to double? So here, this is again population growth model. So if we take, let P be the number of bacteria after T hours, then we know the population growth model. We know P is equal to lambda into e raised to kt. Here it is given when t equal to 10, P has become 5 times lambda. This is the initial number of bacteria at the beginning. In 10 hours, it has increased 5 times. So, when t equal to 10, P equal to 5 lambda implies 5 lambda equal to lambda into e raised to kt. E raised to 10k. T is 10. From this we get e raised to 10k equal to 5. Let us take log on both sides. If we take log on both sides, we have 10k log e, which is 1, equal to log 5 to the base e. Log 5 is 1.609. From this, k is equal to 1.609 divided by 10. It is 0.1609. So this is k. Now we need to find the time it takes for the number of bacteria to double. We got k as 0.1609. Let us take this as 2. Now for P equal to 2 lambda, 1 implies 2 lambda equal to lambda into e raised to k. K is 0.1609 t. 0.1609 t. This is from 2. Lambda lambda will go. This implies 2 equal to e raised to 0.1609 t. Let us take log on both sides. Log 2 to the base e equal to 0.1609 t. Log 2 is given here. It is 0.693. 0.693 equal to 0.1609 into t. From this we get t as 0.693 upon 0.1609. This when we divide, we get it as approximately equal to 4.3. Therefore, the time taken for bacteria to double is 4.3 hours. The time taken for number of bacteria to double. Equal to 4.3 hours. So based on what is given in the question, we have found the answer using the population growth model. Next question. The amount of oil which is pumped from one of the wells decreases at the continuous rate of 10% per year. When will the well's output fall to 1/4 of its present value? So here it is given the amount of oil pumped from one of the wells decreases at a continuous rate of 10% per year. So it is a decay model. We need to find the time in which the output will fall to 1/4 of its present value. So let us take, let A be the amount of oil for T years. Then we know the exponential decay model, A equal to A0 into e raised to minus kt. And here it is given, it decreases at a continuous rate of 10% per year. Given K is 10%. K is equal to 10%, which is equal to 0.1. So 1 implies A equal to A0 into e raised to minus 0.1 t. We need to find the time in which the well's output will fall to 1/4 of its present value. For A equal to A0 by 4, 2 implies A0 by 4 equal to A0 into e raised to minus 0.1 t. A0 will cancel. If we cross multiply, we get e raised to 0.1 t equal to 4. This e raised to minus 0.1 t, it is nothing but we get 1 by 4 equal to 1 by e raised to 0.1 t. So if we cross multiply, we get e raised to 0.1 t equal to 4. This 4 is 2 square. Now let us take log on both sides. We get 0.1 t log e, which is 1, equal to 2 log 2 to the base e. Log 2, it is given here 0.693. So this is 1.386. 0.1 t is 1.386. Therefore, t is equal to 1.386 divided by 0.1, which is 13.86. Therefore, output falls to 1/4 of its present value in 13.86 years. The output will fall to 1/4 of its present value in 13.86 years. Next question. A cup of tea with temperature 95 degrees Celsius is placed in a room with a constant temperature of 21 degrees Celsius. How many minutes will it take to reach a temperature of 51 degrees Celsius if it cools to 85 degrees Celsius in 1 minute? So here the initial temperature of the cup of tea is 95 degrees Celsius. It is placed in a room with constant temperature. So the surrounding temperature or the room temperature is 21 degrees Celsius. We need to find the time it will take to reach 51 degrees Celsius if it reaches 85 degrees Celsius in 1 minute. So this is the condition which is given. We have to find the time it will take to reach 51 degrees Celsius. Let us take, let T be the temperature of the cake after T minutes by Newton's law of cooling. We have T minus A equal to lambda into e raised to minus kt. given A is the surrounding temperature. So the surrounding temperature is given as 21 degrees Celsius. And then it is given the initial temperature of the tea is 95 degrees Celsius. That is, when T equal to 0, the temperature is 95 degrees Celsius. So from this we have 95 minus 21 equal to lambda into e raised to 0. Or from this we get lambda as 74. Therefore, from 1 T minus 21 equal to 74 into e raised to minus kt. We are substituting A and lambda. A is the surrounding temperature which is given as 21 and lambda we just now found it is 74, that we are substituting here. Now let us take the condition which is given here. It cools to 85 degrees Celsius in 1 minute. For T equal to 85 degrees Celsius and time T equal to small t equal to 1 minute, 2 implies from equation 2. 85 minus 21 equal to 74 into e raised to minus k. 64 equal to 74 e raised to minus k, we can write it as by e raised to k. So from this we get e raised to k as 74 by 64. This 74 by 64, the value is approximately 1.156. If we take log on both sides, we get k log e. Log e is 1 equal to log 1.156. The value is given here. It is 0.145. Therefore, k is equal to 0.145. Let us take this as 3. And now it is asked, how many minutes will it take to reach a temperature of 51 degrees Celsius? For T equal to 51 degrees Celsius, 2 implies 51 minus 21 equal to 74 into e raised to minus k is 0.145. 0.145 T. We have 30 equal to 74 upon e raised to 0.145 T. Let us cross multiply. When we cross multiply, we get e raised to 0.145 T equal to 74 by 30. This 74 by 30, it is approximately equal to 2.47. Let us take log on both sides. 0.145 T equal to log 2.47 to the base e. Log 2.47 to the base e, the value is 0.904. This is 0.904. From this we get T as 0.904 upon 0.145. This is approximately equal to 6.23. Therefore, temperature reaches 51 degrees Celsius in 6.23 minutes. So this is the answer. The temperature will reach 51 degrees Celsius in 6.23 minutes. Moving on to the next question. A cake is removed from an oven at 250 degree Fahrenheit and left to cool at room temperature, which is 70 degree Fahrenheit. After 30 minutes, the temperature of the cake is 150 degree Fahrenheit. After how much time will it be? 100 degree Fahrenheit. So again, this is Newton's law of cooling. Here, when the cake is removed, the initial temperature was 250 degree Fahrenheit and the room temperature is given as 70 degree Fahrenheit. It says after 30 minutes, the temperature of the cake becomes 150 degree Fahrenheit. You need to find the time in which it will become 100 degree Fahrenheit. So let us take, let T be the temperature of the cake after T minutes. By Newton's law of cooling, we have T minus A equal to lambda into e raised to minus kT. Given A equal to the surrounding temperature 70 degree Fahrenheit. And then for time T equal to 0, the temperature is 250 degree Fahrenheit. Initially, when the cake was removed, the temperature was 250 degree Fahrenheit. So from this, one implies 250 minus 70 equal to lambda into e raised to 0 at time t equal to 0. So here we can substitute 0. E raised to 0 is 1. From this we get lambda equal to 180. Therefore, T minus 70 equal to 180 into e raised to minus kT. So this is the model for the temperature. And now it is given after 30 minutes the temperature of the cake is 150 degree Fahrenheit. For T equal to 30 and temperature 150 degree Fahrenheit, 2 implies 150 minus 70 equal to 180 into e raised to minus 30k. So we are substituting the temperature as 150 and the time as 30. This implies 80 equal to 180 upon e raised to 30k. Or we get e raised to 30k as 180 upon 80. This when we divide, we get it as 2.25. If we take log on both sides, we get 30k as log 2.25 to the base e. The value is given here. It is 0.811. Therefore, k equal to 0.811 divided by 30. This when we divide it is 0.027. So we get k as 0.027. Let us mark this as 3. Now we need to find the time in which the temperature becomes 100 degree Fahrenheit. For T equal to 100 degree Fahrenheit, 2 implies 100 minus 70 equal to 180 into e raised to minus 0.027 T. In place of k, we can substitute 0.027. This is from 3. Or from this we have 30 equal to 180 upon e raised to 0.027 T, or e raised to 0.027 T equal to 180 divided by 30. This is 6. Let us take log on both sides. When we take log on both sides, we get 0.027 T equal to log 6. Log 6 is given here, it is 1.792. Therefore, T is equal to 1.792 by 0.027. This when we simplify, we get it as 66.37 minutes. Or it is equal to 66 is 1 hour 6 minutes. Therefore, it will become 100 degree Fahrenheit in 1 hour 60 minutes. Therefore, it becomes 100 degree Fahrenheit in 1 hour 6 minutes. So this is the time in which the temperature of the cake will reach 100 degree Fahrenheit. Next question. Radium decomposes at a rate proportional to the amount present. If half the original amount disappears in 1600 years, find the percentage lost in 100 years. So it is given radium decomposes at a rate proportional to the amount present. Here we need to find the allocation of marks for such question. If the allocated marks is 4, then we have to derive the model. If the allocated marks is less, we can write the model directly and we can find the answer. So here I am assuming this is for 4 marks and let us derive this model. Here it is given radium decomposes at a rate proportional to the amount present. Let us take let A be the amount of radium after TS. So here it is given dA by dt equal to minus Ka. Radium decomposes at a rate proportional to the amount present. So dA by dt equal to minus Ka. From this we get dA by A equal to minus K dt. Let us integrate both sides. If we integrate both sides, we get log A to the base E equal to minus Kt plus C. Or by definition of logarithm, we get A is equal to e raised to minus Kt into e raised to C. Or we have A equal to A naught into e raised to minus Kt. So this is the model. A equal to A naught into e raised to minus Kt. Finding the general solution of the differential equation will carry usually 2 marks if it is a 4 marks question. Accordingly, we can write the steps. Now let us proceed with the question. If half the original amount disappears in 1600 years, given A equal to A naught by 2 for T equal to 1600 years. 1 implies A naught by 2 equal to A naught into e raised to minus 1600 K. Or we get half is equal to 1 by e raised to 1600 K. When we cross multiply, we get e raised to 1600 K equal to 2. If we take log on both sides, we get 1600 K equal to log 2 to the base E. Log 2 to the base E is 0.693. It is given here. So from this we get K as 0.693 upon 1600. Now this when we divide, we get it as 0.0004331. And now it is asked, find the percentage lost in 100 years. First let us find the amount lost in 100 years and then we will be able to find the percentage lost in 100 years. So for T equal to 100, let A equal to x into A naught. Here when we see half the amount disappears, we take A equal to A naught by 2. Here we are assuming that x part of A naught is lost. So we are taking A equal to x into A naught. 1 implies x into A naught equal to A naught into e raised to minus 0.0004331 T. T is given as 100 into 100. So A naught and A naught will get cancelled. We get x is equal to e raised to 0.04331. Now the value of e raised to minus 0.04331 is given as 0.9576. This is equal to 0.9576. So we got the value of x. So the amount lost will be equal to a naught minus x into a naught, or it is a naught into 1 minus x, which is a naught into 1 minus 0.9576. So this is a naught into 0.0426. I'm sorry, 24. So the amount lost is 0.0424 of the initial amount of radium. So percentage lost will be, therefore, percentage lost equal to 0.0424 into 100. It is 4.24%. So this is the percentage of radium lost in 100 years. Next question. Half-life of radioactive carbon-14 is 5700 years. A certain bone was observed to contain 75% of carbon-14 as compared to what is present in living creatures. We need to find its antiquity. Antiquity means we need to find the age of that bone. So let us take, let A of B be the mass of carbon-14 after T years. Then we know the decay model. We have A of t is equal to A naught into e raised to minus kt. Let us take this as 1. Given A equal to A naught by 2 for t equal to 5700 years. Half-life is 5700 years. The meaning is that the amount of carbon-14 becomes half of it in these many years, 5700 years. So A becomes A naught by 2 in t equal to 5700 years. 1 implies A naught by 2 equal to A naught into e raised to minus 5700 k. Or from this we get e raised to minus 5700, e raised to plus 5700 k equal to 2 when we cross multiply. If we take log on both sides, we get 5700 k equal to log 2 to the base e. This log 2 to the base e is 0.6931. 0.6931. From this we get k as 0.6931 upon 5700. So this, when we divide, we get it as 0.0001216. Now we need to find the age of bone which was observed to contain 75% of carbon-14 as compared to what is present in the living creature. So what is present in the living creature is A naught. That will be the initial amount that was present in the bone so many years back. Now A equal to 75% of A naught, that is 75 by 100 into A naught. This is 3 by 4 A naught. 1 implies, let us write k separately, 0.0001216 and mark this as 2. 1 implies 3 by 4 A naught equal to A naught into e raised to minus 0.0001216 t. A naught and A naught will cancel. Let us cross multiply. If we cross multiply, we get e raised to 0.0001216 t equal to 4 by 3. Let us take log on both sides. If we take log on both sides, we get 0.0001216t equal to log 4 minus log 3. Using the properties of logarithm, log a by b equal to log a minus log b. Using this property, I have written this, or we can write it here also. Log a by b equal to log a minus log b. So from this we get 0.0001216t. This 4 is 2 square equal to 2 log 2 minus log 3. Log 2 is 0.6931. So this is 2 into 0.6931 minus log 3 is 1.0986. 1.0986. So this is 1.3862 minus 1.0986. Just when we subtract, we get it as 0.2876. Now we can find t. It is 0.2876 upon 0.0001216. So this is 2876 upon 1.216. So this when we divide, we get it as 2365 years, approximately 2365 years. So t is equal to 2365 years. So the age of the bone is 2365 years. Therefore, age of bone. This bone, which was observed to contain 75% of carbon-14 as compared to those in living creatures, its age is 2365 years. Moving on to the next question. If 600 grams of a radioactive substance are present initially and 3 years later only 300 grams remain, how much of the substance will be present after 6 years? So here initially 600 grams of radioactive substance was present and 3 years later 300 grams remain. We need to find the amount of substance that will be present after 6 years. So let us take, let A be the amount of radioactive substance after t years. Then we have the exponential decay model given by A equal to A naught into e raised to minus kt. It is given at time t equal to 0, A equal to 600. This implies 600 equal to A naught into e raised to 0, or from this we get A naught equal to 600. Therefore, A equal to 600 into e raised to minus kt is the model. It is given 3 years later only 300 grams remain. For t equal to 3, A equal to 300, 2 implies 300 equal to 600 into e raised to minus 3k. Or when we cross multiply, we get e raised to 3k equal to 2. Let us mark this as 3. Now we need to find how much substance will be present after 6 years. For t equal to 6, 2 implies A equal to 600 into e raised to minus 6k. Or this is equal to 600 divided by e raised to 6k. E raised to 6k is nothing but it is e raised to 3k the whole square. e raised to 6k is e raised to 3 into 2k. So this 3 into 2 into k we can write it as e raised to 3k the whole square. E raised to 3k we got it as 2, that we can substitute here. So this is 600 upon 2 square. It is 600 by 4, which is 150. So this is from 3. Therefore, A is equal to 150 grams. How much of substance will be present after 6 years? After 6 years, it is better to write like this separately at the last. The answer, 150 grams of the substance will be present. So this is the answer. Next question. The space vehicles are supplied power from nuclear energy derived from radioactive isotopes. The output of the radioactive power supply for a certain satellite is given by the function y equal to 50 into e raised to minus 0.004 t, where y is in watts and t is the time in days. How much power will be available at the end of 90 days? How long will it take for the amount of power to be half its original strength? So here the model is given. The model is given by y equal to 50 into e raised to minus 0.004 t. Y is in watts and t is in days. We need to find the power that will be available at the end of 90 days. First subdivision, first let us write what is given. Given y is equal to 50 into e raised to minus 0.004 t. A we need to find for t equal to 90. Y equal to 50 into e raised to 0.004 into 90, or it is 50 into e raised to minus 0.36. E raised to minus 0.36, the value is 0.6977. This when we multiply, we get it as 34.885 watts. So the power available at the end of 90 days is 34.885 watts. 34.885 watts will be available at the end of 90 days. Next subdivision. How long will it take for the amount of power to be half of its original strength? We need to find the time in which the amount of power will be half of its original strength. So B, here from the model we can find the power that was available initially. At time t equal to 0, y equal to 50 into e raised to 0, or y naught, let us take it as y naught equal to 50. Now we need to find the time taken for the power to become half of its original strength, that is half of 50. For y equal to 50 by 2, which is 25, we have 25 is equal to 50 into e raised to minus 0.004 t. Let us cross multiply. Let us take the given model as 1. This is from 1. E raised to 0.004 t equal to 50 by 25. It is 2. If we take log on both sides, we get 0.004 t equal to log 2 to the base e. log 2 to the base e, it is 0.6931. So from this we get t as 0.6931 divided by 0.004. This is equal to 173.2. So the power will become half of its original strength in 173.2 days. Power becomes half of its original strength in 173.2 days. So this is the time in which it will become half of its original strength. Last question. Use the exponential growth model to show that it takes for a population to double, that is from an initial number a to 2a, is given by t equal to ln 2 upon k. So here we have to use the exponential growth model to show that the time taken for the population to double is ln 2 by k. So according to exponential growth model, we have p is equal to lambda into e raised to kt. Here they have given a, so let us take p is equal to a into e raised to kt. When p equal to 2a, 1 implies 2a equal to a into e raised to kt. If we take log on both sides, log 2 to the base e equal to kt. Log 2 to the base e is nothing but it is the natural logarithm of 2, which is also written as ln 2. Ln 2 equal to kt or t equal to ln 2 by k. This is what we have to prove, and we have proved. Hence t equal to ln 2 by k. With this, the exercise is over and the unit and the part of the unit on differential equations is over. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. Thank you for watching.